I'm trying to think if it's possible that, well, you always have like unknown actors, but if you know all the actors in the supply chain, you could also say everybody has to put in a deposit of their good behavior. So if you kind of screw up in the system, then you might lose a deposit, for example.
So coming back to your previous question about like handling if that you don't know if you're talking to a computer or
Yeah.
What about illegal activity? So what if both like a human and a computer working together on making, let's say, an illegal substance or something like that?
Oh, that's cool.
Because you don't like now you assume the good of that machine is that neutral, but like it's most likely good because
Yeah.
so that's just assumption, right? So different like the contrary.
An automated weapon or something.
Yeah, exactly, or something like that.
Killer drones.
Because how do you control that? If it's system, or you don't have to control it, how do you evaluate such a thing?
So, yeah, again, that's kind of like looking at, well, these two, that human-machine interaction went really smooth and they created something. For them, that's kind of value creation right there, which could be a massive explosive or what have you. So they're good. They're happy both. They did a transaction and they both, the machine got the money and the human got the interesting goods. And then one of the things that you're now trying to see is that, well, somebody detects that, hey, these guys made a machine, and at the end of that supply chain of a machine was a machine that was autonomous. Should we now allow other autonomous machines to go in future transactions and do this kind of barter where you say, well, create me something, print me a gun? I guess that's possible. Yeah, so now we're talking really about governance of these things. Huh? I guess governance is going to be all around these things, these networks and these algorithms. Having them full autonomous is pretty much an ideal. Having gradual layers of, let's say, you could start with a sandbox and say that everything the machine does has to be whitelisted first a few times by humans. And know what? If you're using a blockchain, then we can start tracking all the provenance of all the actions that the machine did. So we kind of know exactly what the machine did at which point in time. We know this entire provenance because the machine is connected to a blockchain. Now, imagine there is like the machine makes a decision. I think one of the most interesting decisions that a machine has to make is when we're thinking about autonomous vehicles driving. And you're sitting there, the car is driving, and then suddenly there is either a tree or an old lady crossing the road, and the car has to make a decision. Will it kill the driver, or will it kill... something will get hurt. What gets hurt? So that's going to be a few precedents that will definitely happen. And then humans kind of have to say that, well, in this case, I don't know, I don't want to make like a judgment call on this exact thing, but we all agree that the older lady was maybe a bit...
First time is up.
Yeah. So in future... So, I mean, the other thing you could say is cars cannot make decisions at this point in time, and at some point the driver will get alerted and say that now you have to take control because I don't want to deal with this. Right? That could be the other opportunity that you have. But interestingly, many of these things can either whitelist or blacklist, or graylist, or put in like a staging environment, like a test environment, and things that have proven to be very mature and robust, like human decisions or social or ethical decisions to be made. If they can be encoded in machine language to some form, in that decision-making diagram, saying that, yeah, those outcomes are interestingly ethically. We're going to allow these ones, we're going to whitelist them. Other ones we're going to blacklist. And then blockchains actually, again, come in quite handy because you have a public list of actions that the machine can do and cannot do. But you can also use incentives for people to maintain that list and to make sure that list has more like a community-created version of it, where the community kind of starts playing crypto token games, stakes / you can basically, if you vote one out and everybody follows you, you get more tokens, and if your vote was successful, you don't lose your vote token or what have you. There's many interesting games you can do there. There is even a concept around it called token create registries, which is basically how, as a community, we can maintain a wide list of actions. And it's a form of governance of what's allowed and what not. You could say it in an extreme form, it would be your legal law book, Lex, whatever, how it's called, yeah, that book, but then more on a machine level, maintained by a community of humans. I think I've been talking for too long, and I do want to know if we have updates.
We are live with 2 streams, but in Berlin, your colleague is still talking.
Who is that? Thibaut.
Thibaut is talking in Berlin.
From Parity.
Yes, exactly. He should be over around right now. And we are just waiting for the signal from Berlin for them to join us.
Okay.
And, when this
Or what we can do is enjoy the last minutes of Thibaut.
You want to enjoy? Do we know? I do want to see Thibaut. I never saw him.
Okay.
Let's meet Thibaut.
Has to be built in Wasm. So basically, you build it in CC++.
That's Thibaut. Yeah, nice guy.
So hot upgradable runtime, I was saying. So this runtime, you have to build it. That's the thing that you build. We give you like everything that's around, and we let you build the runtime because that's what makes your blockchain so unique, right? And it has one function which is exposed to the outside, to the substrate, and that's execute block. And this function is really cool because it can allow you to upgrade itself. So basically, this Wasm runtime, what you have built, you can basically tell itself to, okay, starting from next block, you will not use this executable, you will use another one. So you basically replace, a bit like, I don't know, you know when you upgrade, or you don't even see it, right? When you upgrade your browser, Chrome, you just shut it down and turn it on again, and then it's the new version, you didn't even see it. Okay, this can happen without shutting it down and turning it on again with this hot upgradable runtime. And we did actually use this when switching from our proof of concept 1 to proof of concept 2. So those are testnets that are live today already. And we did use this, so we did an on-chain upgrade. I have probably 1 minute for this one. But it's actually really interesting to understand,
what we see here is
how do I do
an interesting project called Parity Substrate. Parity known to anyone? Like a few? It's Substrate is the product they're building. They built Polkadot, they built the Web3 stack. One of the founders of Parity is called Gavin Wood, and there's this, he basically designed Ethereum. And so Ethereum is this decentralized smart contract platform. It's also a very famous cryptocurrency that you use to use the platform and run your smart contracts. And what these guys do is they want to take this to the next level. So they say what they see is that there's a lot of blockchains out there. You have the Ethereum ledger, you have Dfinity, you have a lot of projects running their own ledgers and their own blockchains. What they actually built is something that's called Polkadot, and what it does, it connects all these ledgers. So basically, it's what the let's say what TCP/IP protocol did for connecting computers, they do to connect blockchains. So this means that one blockchain can run smart contracts and then suddenly call another blockchain and ask, for example, how many Bitcoins do you have, or how many Zcash do you have, and with that, they're going to make decisions. So what he's explaining here is like a bit of the fundamentals of their technology. And one of the more interesting things they're looking at is something called WebAssembly. WebAssembly is a language. Basically, it's a full functional language that can compile in your browser. So what they're building is code that can just run in your browser. It doesn't really need a specific operating system, like Windows or Linux or Mac, but any browser would do. So since it's called Web3, a lot of the stuff will go through browsers, and having code that's fully compliant with the browser helps. And WebAssembly, well, it's quite a new standard, but it's getting like very, very much attention from these crypto kids, like this guy. And it can do a few very interesting things. So there is a project called TrueBit, which is using also WebAssembly. And what they do is they can make that WebAssembly, that very complex code, they can make sure that you have a proof that somebody run this on their browser. You don't have to run this on 10,000 computers. Just one person has to run it, and I can give you a cryptographic proof and say that I did this, and nobody can dispute that I didn't do it. So this makes this entire blockchain concept more like a verified compute concept, which also means that it can scale tremendously. So this means that at this point in time, using that technology that I just relayed, we can do a few interesting things here. Let's map it back to our story we had with the river and the forest and the trees. So we have this WebAssembly thingy. Imagine you have a robot, and that robot needs to run code because it needs to make a decision. At that point in time, how do we trust that that robot actually makes the right decision and runs the right code? You could say, well, it runs on 10,000 similar robots, and they all have to agree, and then that's the thing that a robot would do. Or you use this WebAssembly thingy, and the robot runs its code in this special format and gives you a proof that it actually did it. At that point in time, you're quite sure and know that, oh, that robot did its job well, and now we can reward it, or we cannot. So, yes. We are ready? There is a beer and the water here. Oh, well.
And JP, Owen?
Ja? Genau. Alles klar? We are on the internet. Perfect. Hi, everyone, and the people that I cannot see because they're in a different country. My name is Dimitri. I'm from BigchainDB and Ocean Protocol. And today, I'm going to keep it quite short from my side because I already tired the people here in Amsterdam. And I'm just going to explain a bit what we're trying to do with Nature 2.0, what this exact session is about, or should be about, or at least we try to frame as such, what we did in the previous session and what we're going to do in the next session, and then leading up to the hackathon. So, an overview. This is what we've done last time. The blue thing, the hive mind, is what we're going to do now. And self-actualization is a workshop on the 6th of January, I think. JP? The last...
It's January 16th.
January 16th is then the next one, and talking about self-actualization, and then we're also looking more into the legal side of things. How can we put these machines in a legal vehicle? Right. So I'm going to give you a bit of a recap of what happened in the last session, the plugged-in session. Oh, maybe just to show you, like, this was a bit of my thinking, like, to not make it too complex, because there's a lot of steps you can put in between. But what I was thinking was, well, if you create something like autonomous resources and decentralized autonomous nature, you might follow a bit of a methodology, and this is just one proposal. First one is plug in the machines, make sure that they all have a wallet and everybody's equal, and everybody can do transactions, whether you're a machine, whether you're a DAO, whether you're a DAO governing a resource, whether you're human, we all speak transactions and wallet. So this plugged in, it's basically is like retrofitting existing devices, hardware, software, and they all speak transaction. The hive mind is, well, now we have these agents in the system defined by a wallet, and the hive mind is now going to look at coordinations. So we have Kryha, we have Oddbot, we have other people in Berlin, and they're all going to give us their ideas on how to have this coordination between those machines, and maybe they're even looking at empathy or ethics at some point, I think. And then one step further is self-actualization, and that's basically saying that, well, how human can we make these things? Can we have encode a few interesting laws or ethics into these machines? Can we type them into legal code? So what happened last time? We had, also this is a series, 3 series, where we go a bit deeper into the technology as well, such that this all leads up to a hackathon. And the hackathon is going to be the Blockchain Hackathon. I guess it's in Groningen every year. It's really big, and it's a lot of fun. You can see how much fun the people have. And what we want to do is we want to make sure that everybody understands the concepts that we're talking about, gets a little bit of a feeling of the code, because so many things are happening in the space. So a bit of like saying that this is useful, this is not useful helps. And also just meet with us and talk with us and give us new ideas. So on the 28th of January, another important date, then you can start subscribing with teams towards this Nature 2.0 track to participate in the hackathon. And there's a lot of really cool bounties attached to it, a few special treats that we have for you. And in the last session, we were looking at a few technology providers. One of them is Interlinked. Interlinked is all about digital twins. How can you create a digital representation of a physical thing? Our digital twin is everything we gave to Google, basically, and they now have our digital twin. But a digital twin could be, for example, for a robot, could be a trace of all the things he did, all these actions, maybe in a provenance graph. That could be the digital twin of a robot. And interestingly, if you have a digital representation for a physical item, you have this one-to-one mapping, and you sometimes need to have special hardware to do that. So this hardware can be provided, and we have a few really cool companies doing so. One of them is called Weave.network. And Weave is working with secure operating systems. What does this do? This means that you can have a little device. It's an ARM chip. I think that's in most mobile devices available. And there is something called a trusted enclave. A trusted enclave is like the secure box within the hardware where nobody can look into, and the only thing that comes out is correctly run code together with the cryptographic proof that that code got run. So you cannot cheat the device. You cannot spoof the device. You cannot create a clone of the device. There's only one device, and that's identified by that secure hardware. And Weave provides you, well, it's common hardware, everybody kind of have it, and they give you like this nice operating system to manage the secure enclaves and stuff. So their code is on GitHub. These guys probably will put some code on GitHub as well. And then we have Xane, robot. It's basically one of those embedded devices. And it has a lot of, it's like this, you know, this running robot, and it has a lot of, way too many cameras. It's a bit over-engineered, but it also has artificial intelligence on that embedded device. So what they do use it for is races. So this can follow a track. I think Oddbot's device can also follow tracks. It basically can run around and race against others. And all the artificial intelligence is on the robot itself. So it doesn't have to compute in the cloud. It's all compressed onto the robot. So with that, we can all make a lot of fun toys already. Today we'll be looking more at global systems, like for example, decentralized energy, or yeah, grids, or maybe even that Terra Zero thingy. And we're looking less into a single agent, but more like groups now. And that's what we're trying to look for today. Also, there is this pyramid of Maslow that well, I think that kind of maps a little bit to what we can do. This is kind of saying that in order to become a self-actualized being, you need to have a few layers of activation. At the lowest level, you need to have your physical needs, like food, water, shelter. One layer above, you need security. You need maybe legal status, other kind of safety needs to survive. And once you know how to survive, then you might want to create social circles, communities, friends, empathy, and then you maybe want to go one step further and have this form of self-achievement and doing something for your community and becoming more active. And in the end, you could say there is a layer of intelligence. And for each of these, you can actually start designing for agents, how would that look like? Can we create some form of API or some form of minimal code to experiment how machines could express empathy? For example, if a machine can ask another machine like, hey, what do you need? Okay, I won't touch that. I give you the space to operate right there, for example. So a lot of experimental stuff. I think the slides and all of these things are on the website. Otherwise, we will put them there. And then in the previous session, we went over each of these and we kind of gave a hint of how would this look like. Now, today, I'm going to give a little bit of an overview of how we can help with Ocean Protocol ourselves. I'm at the research side of things, and with Ocean Protocol, what we're trying to build is something like a public intelligence network. You could call it a machine learning marketplace or a data marketplace, but in the end, it should be a public marketplace, a public network with a lot of free data, a lot of free AI, not owned by big companies. But everybody has access to that artificial intelligence. That's what we're trying to do. And to give you a bit of an idea, think about how, well, this is how we model the world. This is all we need to know for Ocean Protocol to model the world. We want to create something like decision-making trees and supply chains for machine learning, and it's always the same thing. You have data, you have algorithms and data come together, they compute something, and that compute could be a prediction, could be a classification of things, could be a lot of interesting things. For example, let's try to build a virtual human agent. This is actually something we do with a Japanese company, Cougar. And yeah, they make manga stuff out of everything, but they have this virtual human agent, and it has a few. So this is like this digital agent, and it can jump from screen to screen and interact with you, and actually knows what's happening in the room and react to it. How does it do that? Well, first of all, it needs to know what's happening, so it needs to look around. It has camera images, and then it responds to speech. In order to have something that can detect objects, you need a lot of image data that's labeled and saying, this is a dog, this is a chair, this is a thing. And if you have many, many of these things, you get basically, you can have a computer classify images that it hasn't seen before. So if it sees 10 chairs, maybe at IKEA or what have you, from the catalog. And then you have a chair that's, you take a picture from here, and then the AI can quite well predict that it's also a chair, given on those 10 chairs it has seen before. The same for speech. Speech will then go into natural language processing and gets context attached to it, and then you have your chatbots and all these things. So creating a virtual human agent is basically a data supply chain. The supply chain going from labeled data, from unlabeled data, etc., and then basically goes into these things called neural networks. Interesting neural networks are convolutional neural networks. They can look at images, they can look at speech, they can look at other things. And then if these things come together, you basically have something that can predict objects, classify objects, predict speech, interact, etc. So what we're thinking is, well, if you create a blockchain version out of it, then one of the things you're going to do is saying that, well, everything here, every component is a service that we want to offer to an open market. And if you want to interact with that service, you have to buy the contract of that service. So on the internet, there is this thing called service level agreements, saying that Amazon guarantees you that 99.99% of the time, they will always be up. If we go to work and then sometimes Slack or GitHub go down during the operational day. So if Slack goes down, we have no communication with the team whatsoever. If GitHub goes down, we cannot communicate across code. So service level agreements allow these services to basically, well, they allow mutual protection, saying that if you don't deliver the algorithm, then you're not going to get paid or you might get penalized. So it basically says that all the people consuming these resources are protected from both ends. And we have flexible contracts to do so. So what we really want to build is not just one service in each, but basically a multitude of services. Saying that you can have open markets. It's not like a big supermarket. It's going to be more like a bazaar where everybody that has something interesting can push it to the network. If you're a data scientist late at night at home and you build this amazing neural network and you say, well, I'm just going to throw it on the market, see if I can make some money out of it. That should be possible. If you say, well, this is cool for the community. It's something that I want to give away for free. I just want to get accreditation. That's also possible. And we don't model as such as a really economical marketplace. It's more like a tribe, problem-solving tribes. So just to give you an idea, there's a lot of existing services and new services that are emerging into this data science market. And we have big cloud providers like Amazon and Azure. We also have decentralized prediction networks like Numerai, SingularityNet is a marketplace. We have specific type of privacy-preserving computation like Enigma. We have Trubit. There's so many things that you kind of want to connect into full supply chains. You don't not only want to use the computation here, but you want to also connect it to the next one and the next one and the next one and create like full solutions with data science. And that's what we try to solve with Ocean Protocol. Basically create a graph, a data pipeline, a supply chain of intelligence. And not just because we can, but because we think that if you put in the right incentives in this system, you're going to create data supply chains that can solve problems that are related to long-living problems like sustainable development goals. We think we're trying to set something up that's called AI for Good, AI Commons, and ImpactNet. And that's basically saying that people can post problems in this network, and they have a bounty attached to it. And if you find a data service supply chain that can solve the problem, you basically win the bounty. And then the question is, what kind of problems to be solved? A few of the problems to be solved is, for example, looking at how can we measure coral bleaching in the oceans? How can we predict, for example, and that's a really cool one. There's a lot of health companies and universities and hospitals that are gathering a lot of data about skin. And sometimes you have a mole on your skin, and most of the times that's not a problem. And a few times that's actually a malicious tumor, so skin cancer. So what we're looking at is, can we make an automatic classifier that you just take a picture of your skin, you upload it to the network, and if it's robust enough, it won't give you false positives. But it could assist and proactively early warn people that you might have a problem. So this is that's an interesting project. And other projects are around, let's say, autonomous driving, for example. We had a few others. And what we're trying to do is set up this type of tribes and communities that basically govern their problems. They put funds in it, and they set it up as a bounty. And then people, data scientists, and data providers can work in this network, and they can try to solve these problems and get rewarded for it. So one of the things we're working around is Mobi. We have a very big prize around autonomous driving right there. If you go to Mobi network, then you can see what that exactly means. This is, I just talked about that. That's the healthcare example. Other things that are fun is to look at, well, now you have all these assistants. You have Siri, Alexa, you have your Netflix recommendation engine, and you maybe have your vocabulary, etc. And they're all owned by different services. Is it possible to basically collect your recommender or your assistant on your phone, carry it with you all the time, and learns about everything you do fully horizontal, but never gives it away to somebody because it stays on your phone? So then you really get your digital assistant next to you. And maybe we can look at what collective intelligence can do. But that's something I will leave to the guys from Kryha to figure out and to indulge us. Those communities themselves, well, we're working a lot around decentralized autonomous organizations, which I can explain before. This typically it's about crowdsourcing and crowdfunding, a DAO managing resources, meaning that there's a set of people that can vote how to spend. Terra Zero, connecting this DAO to natural resources, and there's even something called plantoids. This is from an artist, Primavera de Filippi, and she makes this. Basically, you have to interact with this blockchain life form, give it a bit of money, and then it will try to gather enough to create a brother, and then create a family and a community, and just wants to replicate itself. Now, that's it for my talk. Actually, what we want to do is make sure that people here also know a bit about what you can do with Ocean. Here we have, maybe if you want, you can send an email to raindrops@oceanprotocol.com. And now we're just airdropping a few of our tokens, such that if we go live with the network, you can actually play around in the system. And we want to give community members a bit of early mover advantage. So if you, by tonight at 11 p.m., send an email with the subject Hive Mind to raindrops@oceanprotocol.com, we can figure something out to reward you guys. So yeah, I guess that's from my side. JP, do we have time for questions? Do we go to the next talk? We have time for questions? If there are any questions.
You showed something about curating the results of those
Yeah.
compute steps. How do you going to incentivize the curators to do a good job?
Yeah, that's actually a good question. Curation is very important because it allows to separate the signal from the noise, the important stuff from the unimportant things, the relevant from the irrelevant. And it's very difficult to incentivize it. You have to make low friction, and typically we're looking at if somebody bets on something first, how can you have others? But actually to play with this, I might have lost the live stream, but we have this website called musicmap.info. And what we're designing in the back, it's not yet hooked up, but this is basically, we try to build a history of music genres, right? So here you see, for example, the 1900s, here you have the 2000s. this is blues, jazz. Here we have EDM emerging. We have some early electronic music. We have rock and roll going into contemporary rock and etc. Right? Well, the fun thing is you can actually zoom in into this map. Whoops. And then you see distinct genres. Right? You can see where they come from, where they're going to, what influence what. And the fun thing is you can click on them. If you click on them, you get a bit of like Wikipedia-style text around it. But the real fun thing is that you also have a playlist. So for each of these genres, and then you can have like visual discovery of music. Yeah? And what we really want is to have every song in the world classified in this universal map of music. But it has to be community curated. You can imagine, I don't know who here is a ska, punk, ska core fan. If I put this on and if there is a fan in, he would say, that song shouldn't be there, that one should be on level 1, and everybody has an opinion, and some of them have more opinion, and now we can play interesting games. How can we maintain the lists here, curate them? Because here we're doing a simple machine learning task, a data engineering task actually. You say, take a song, which kind of zeitgeist, genre, can we attach to it? What's the community consensus around this? So we're bounding out all the steps of making this, because we have to do some other stuff in the meanwhile, but we're bounding everything out, and we have all the designs ready, so people that want to, within a month or something, all the little steps on how to build the system together with us, it's going to come online. And then one of the cool things is that we created a gaming engine, which is just about the incentives. And now we play a few interesting games, like you can earn badges. You might be able, if you're the king of the genre, you might have a few permissions on how do you want the genre to be exposed to the outside world. Do you want to have like a special background to your, maybe you want to have your face up there, have a bit of attention, what have you. We can go as broad as you want, but a lot of fun stuff there. So does that answer your question a little bit?
Yeah, a little bit. I like the concept a lot. It's nice that you show that. So you try to focus on the emotion of people, actually.
Well,
because
yeah.
If you can do any, you can pinpoint any song into any genre if you like.
Please repeat the question for them.
I'll repeat the question. So the question is, if we're talking about emotion and opinion and a very subjective matter, and we want to put this into a system, and who's going to decide what's the actual group opinion. So for this, we use, you can use a few interesting token games.
Like what?
One of them is called token created registries. And that's basically, it's a zero-sum game that says that if you put your proposal on there, people can vote on the proposal. Before you put your proposal out there, you say that I'm going to back it with this amount of tokens. Community does a round of voting. If they agree, you keep your tokens and your things come on the list. If they disagree, they slash your tokens and they divide it. But when they vote, they have 2 camps, and the losing camp also has to take per vote 1 token, and they lose their votes. And the other
Shelling point.
is shelling point, exactly. Yeah. Yeah.
Okay, nice, thanks.
All right. I don't know if I'm plugged in, but so this will be the end of your presentation.
Very good. Very good.
And of your time. We will now have a 10 minutes break for you as well to rest your minds and your brains. You can use this time to, of course, take some drinks and some pizzas. And the bathroom are on your right. Is that me? On your right when you get out down the stairs.
There's
And
also this wormhole thing.
this wormhole thing, we'll take care of that afterwards.
That's
For
afterwards.
now, it's for
Don't-
the break because
Okay,
there's
don't mention the wormhole yet.
yes.
Okay, good. Right.
And yes, of course, you can use Kryha for meeting. And thank you, Jimmy. split screen over there or not? Because there is one speaker has notes and he wants to see the notes. If it's not possible, you tell me it's not possible and he'll deal with it. If it's possible, you tell me. I don't want to put some more stress, it's just a question. No, it's okay.
We should have a second, a little split screen like Panama need to well, does he have two signals or what does he have?
No, it's just that there is a presentation.
Yeah.
There is a presentation and like it's just, you know, like I have my screen and he wants the presenter view on my screen.
Basically, perhaps he can send it. Just getting what he's sending from the HDMI. So if he can put it in that mode, perhaps it works. Otherwise, it can't.
If we can put it in what? Because it's a USB, so it's
If you want to drink, if you want to eat, we start in 5 minutes.
we're about to start, so you can gain your seats and continue this conversation. This works. Yeah, exactly. And we have this pointer. All right, please regain your seats. All right, wonderful. Thank you very much for joining back. We are now back on track. This is now Gert-Jan who will talk to us. I hope you had time to rest your brains. And without further ado, Gert-Jan.
Thank you.
Please, round of applause.
Thank you. I want to talk about the hive mind and how does it decide the need.
Yes.
If I think as myself, as a little kid, I always dreamt about doing magic. Who raise hands? Who also dreamt about doing magic? Yeah, a lot of them. And who thinks it's really possible? Oh, it's a little bit disappointing for the guys who didn't raise their hands, because I want to take you on a journey, and this is not so much a very technical journey, but a more philosophical journey. Because magic seems to be far-fetched, but most things are already in place and are already available right now in a very immature state, but they will emerge in the next 10, 20, 50 years. But first, look at the nature 2.0 ecosystem and the hive mind. If we want to mimic nature, the trap is to think everything has to be very intelligent. If we look at science fiction, we always say this kind of artificial intelligence and artificial life. Always very intelligent, high-class robots. But how intelligent is nature itself? Nature itself consists for 95% of plants and single-cellular beings. This is not 95% of the numbers, but 95% of the biomass, the dry biomass, carbons. And without this single-cellular life, and without these plants and trees, there was no life. Even we, as human beings, we carry along trillions and trillions of single-cellular life, bacteria. Without we cannot live, we cannot be. And to think about the next steps and nature 2.0, we of an ecosystem which can fulfill this high standard of nature itself, we always have to think about these small, single task, simple robots. But how do the small robots work together with a very high intelligent robots? So you have the small ant-like robots who can do just a single task, and who what they work together with the hyper-intelligent robot. How can they work together? If we look at the Buddhism says all is life and life is all, and life flows through us, and it's like a field going through us. If we imagine some kind of field where we say everything that has input, every contract, every smart contract, every need, every possibility is a ripple in the field, and all those ripples influence the field like a sea. And the natural state is a flat state, but every time a wind comes, a ship comes, rain drops, everything, the field is changed. And now imagine this: we just decide that the lowest point is the best point to go. So we can follow this field like a marble rolling down the field to the lowest point. And everything we think, well, we have a need, we make a hole in the field. And if we say we want an obstruction, we put a wall in the field where the marble cannot go. In this way, you have a very simple decision model, because the node, the agent, only has to decide where to go to the lowest point and where not to go the highest point. But the input can be very variable. For an ant-like machine, it can be very near its vicinity. It can have very poor sensors, which can not look very far away, which cannot detect light, which only can follow chemtrails. But the more intelligent node agents, they can see the whole universe. They can see the whole of the Earth. They can have millions and millions of types of input, more than we human beings can have. Now look, how can that work? Let's take a very simple example. This mod has only two goals in this situation. He wants to go towards the light, because mods do like light, but he doesn't want to fly into the flame, because then it gets burnt. So he gets an objective to go towards the flame, and he's got an obstruction to stay away from the fire. If we plot it in a field, we get the objective to go towards flame, but once he gets near to the flame, he gets this obstruction. And in this situation, it only has to go in the donut shape around the flame, and he rolls like a marble in this donut and makes circles around the flame. This is what mods do in real life. They want to go to the flame, they don't want to get burned, so they fly little circles around it. With two simple input variables, you can make a complex behavior in such a situation. If we make a more, if we convert this to robots who deliver, for example, parcels, we can say, well, we don't want to bump into other parcels, so we make a bump over there. We want the parcel to be delivered in this direction. You can imagine the delivery point is over there, and the marble starts rolling down the road. At that moment, his environment is changing. His environment is the hole is moving towards his end goal, and at the end goal, there is his contract to fulfillment of the delivery of the package. But in the meanwhile, he can encounter something like a river, and at this river, he can decide, well, I can drive around it, but it will cost me a lot of energy. But I can also decide to post an incentive in the field and say, I need to go this direction, and if you make it possible for me to go over the water without crossing around, it will deliver. I have tokens for it to fulfill this contract, and maybe some drone will pick him up, or there are bridge building robots nearby, and they build a bridge for him. So at each time it can decide and it can interchange to fulfill its goal. Now, this is a step in our thought to eventually make magic possible. And if we look at the evolution part, at the current day, if you go into a factory, you see caged robots. You see robots that are not safe for human beings. You cannot come close to it. They are programmed to do a single task. They build an automotive robot, for example. They build a part of your car. They are programmed to do an exact movement. They are put on, they switched off and switched on. And gradually, we are moving towards robots that are safe with humans, and they cooperate with humans. Nowadays, if you go to the big industry fairs, you see they call it cobots, that are robots you plug into a table. They can work together with you. They are safe for human beings. You can train them very easily, but still they are trained. We train them to do a single task, and we repeat them like 100,000 times. If you let robots decide themselves, and if they could make own decisions, they can emerge, and they can emerge to a level where they are individuals around you, surrounding you, helping you in a manner other human beings could also help you. For example, with the dishes, or the autonomous system, where a robot designs art itself and sells it on the market. These are autonomous bots, or autonomous agents, who work in a system together with human beings and together in one ecosystem. Now for the magic, if you evolve this further on, there are all kind of techniques already available, like digital dust that moves, that takes in other shape, without based on an incentive you give. And most of the time it's energy what you give, but you can also give them a chemical reaction when they change. And by controlling these digital dust, you have nano robots that are smaller than single cellular life, and they can all work together on the same simple decision model, where you can where you put in a contract for what I need. And I will give you an example. If you, for example, wanted to like a cup of coffee, if I want a cup of coffee now, maybe a waiter is putting in his machine, table 1 needs a cup of coffee. Then over there, a cup of coffee is made, somebody is picking it up, is bringing it here. With the emerging robots, maybe a butler robot will pick it up and bring it over here. But in the nanoswarm robot, you punch in a hole in the field. The field needs to be filled. Maybe there are, on a molecular basis, you can generate a cup of coffee, you can generate the liquid inside and pour energy in it. If all those parts work together, all this technology already available, if you can make those work together, you can really create magic. How to spark this up? We competed last year in the Blockchain Hackathon for the machine-to-machine ecosystem. We created this field ID, this decision ID, with contracts on the blockchain, where you can decide how to negotiate with each other. We made a little simulation around it, where you actually can have robots running around. They don't want to bump into each other, but they want to deliver the packages. So I just flew in for this presentation. I saw the robots are not running, but over there you see the decision making model. You see they don't want to bounce into each other. They want to deliver packages, so they can decide themselves how to deliver robots the package. This was done by the team called Team Oddbot. Nowadays they are actually building robots. They are running in a very limited ecosystem, where they weed, where the agricultural robots, they weed like along the plants. They take out the weed autonomously in a field of crops, using this ID and using this AI technology. Well, these are my thoughts about how you can make decisions based on very simple and very expandable IDs. I don't know if there are questions.
What is the interaction between the robots? How do they exactly, what's the communication? Do they work on feedback from each other, or on coupling, or?
Yeah, the question is how they communicate the robots to each other. It's a very good question, because this is where the blockchain comes in. They put in their as a human being, as a questioner for the field, I put in my needs. I want this cup of coffee, for example. But everybody can put in their own needs, and the needs are put in on the blockchain. And by putting it over there, I don't know how it's going to be solved, but I know it's going to be solved. So another robot, another agent, is picking up this signal, this disturbance in the field, and he will be willing to fill up the hole that is generated. And based on the technology it has, it can pick up the signal or not. So some signals can be picked up by the example of the robot coming near the water. If you cannot build a bridge or you cannot put me over the river, there won't be an incentive for you, so you won't react on this question. But if you are a drone or you are a bridge building robot, you're gonna act at that moment on that incentive. It's actually the same as Dimitri showed us this nice picture of ants doing a very complex task, towing a huge amount of plant with each other. All those ants are just reacting on chemical responses of each other. There's no thinking about it. They don't decide themselves, well, we see a very big object, how can we transport it? They just act. They just do it. There is no thinking about it. And the goal is, if you're going to be if you're going to build an ecosystem, not all agents are going to be able to think about what they are doing.
Yeah? Yeah, nothing, right? Oh. Have you heard like from complexity science and attractor landscapes or this, or attractor landscapes?
Actually, I'm not the very technical. The AI guy is now standing at with his robot on the agriculture event today.
Okay.
So I cannot answer your question if this is from one methodology or not. But the idea is. The idea emerged about energy trading between vehicles. That's where the idea originated from.
Okay, interesting. Maybe we can talk later. I would like to talk with him then. Yeah.
Okay.
Thanks.
We will now have a wormhole session. The famous wormhole session we talked about, and this is the moment when Gert-Jan goes in a room following Melissa over there. Don't go with your microphone, I do need it. And the ones who are interested in asking questions and interacting with Gert-Jan, they can follow him and ask further questions to get to know more about his topic. For the rest, we will have a talk live streamed from Berlin, and afterwards there will be a last presentation from Dan over there in the back. All good? Did you take your decision? There is basically a...
What's the presentation from Berlin?
Sorry?
What is Berlin going to tell us?
That's a very good question. Waterhives, exactly. Deal with it. Take your decision based on that. That's interested? Well, I propose you, Gert-Jan, to already go with Melissa. And all the ones interested in following following Gert-Jan and Melissa to follow them right now. And for the rest, we will now switch with Berlin, switch live with Gert-Jan. They can follow him and ask further questions to get to know more about his topic. For the rest, we will have a talk live streamed from Berlin, and afterwards there will be a last presentation from Dan.
25 seconds delay.
It's quite more than
Did you take your decision? Sorry?
more than 25.
Very good question.
So, good. Waterhives. I will turn Amsterdam down. And the wormhole session is not relevant for us. And for those who have not understood what it was actually an extended Q&A in a separate room. Mea maxima culpa if I have not explained that in detail or in clear enough words to understand. Yeah. So let's give it like a shout out to Liviu. Thank you for hanging in there. Yeah, being last on stage.
Thank you for
Very
having
much
me.
looking for it. And afterwards, we will be here. I'll wrap up afterwards. If you have questions, I'll be here. Yeah, and now join and enjoy him. Do you need your clicker?
It's a little bit like with the techno parties, you know, the best things happens at the end when everybody's tired and the parties.
Best DJs.
Yeah, exactly.
Berlin.
So, first, a few words about myself. My name is Liviu Mantescu. I am a political economist. Have nothing to do with programming and so on. And I worked in macro political economic theory at in Cologne at the Max Planck Institute, and on environmental policy in Brussels and here in Berlin at the Humboldt University, until I decided that I had enough and I need fresh air and I want to expand. So I took some of the theoretical issues from political economy and philosophy of knowledge into practice. The talk today will be about Waterhives. And I want to link a little bit the discussions we had before, namely what we just heard from Amsterdam. Our colleague was saying, for example, the insects were not doing something creatively, they were just acting based on a chemical substance. They were acting instinctually. Thibaut from Polkadot was talking about separate blockchains, that they don't communicate one with each other. The very idea of being is of being connected. You cannot be by yourself. You need to have reference towards something. Otherwise, you cannot exist in yourself. Let's go back to blockchain, to what Thibaut was saying. As soon as you have a blockchain which is not linked to some other things, you created an entity which most probably will parasite. Why? Because it's not able to draw energy, to receive energy from its environment, so it will catch, it will be tended to catch energy by force from the outside. I won't go very deep in this. You can follow some of my thoughts on Medium. There was an article, The Great Transformation. So being means belonging to something, being in relation with something, and means also to contain something. Once you are connected, you exchange information, no matter what that is. The ants exchange biochemical substances, whatever, and based on this they act. So to be is to belong and to contain. Then we have to act. Our colleague from Amsterdam was just saying, they just act. There is no such a thing as just acting. So you are programmed. We are programmed. And to a certain level, we humans, we are programmed. We have our DNA, we have our genes. And as soon as we add acting towards something with intention, then we have creation. We have a creative act. And here we make the distinction between intelligence and instinct. Again, I will not go further into this artificial intelligence, exactly what do I mean. If you got a little bit the idea, if not, please, as I said, you can follow some of my writings on Medium. Then we have the flow. The flow is be acting and presence. Well, I make few notes because usually I'm nervous and I forget my keywords. It is exactly what I told you at the beginning. I moved from the fundamental research to applied research because I wanted to expand. Be acting means to expand. To put it very simple. And presence means be acting and knowing that, or expanding and knowing that you expand. Knowing where you are at and knowing what you are doing. So these are three categories I'm going to follow in a empirical example, which is my project now. I'm founder at Puraqvo, where I was thinking at the following, okay, from a very pure economic perspective, how can we bring money into natural ecosystem restoration? And for this, we need several things. We need data and we need a good communication. So in other words, we need to show that there is, and we need to act. I took one of the problems, like if you go to the doctor and you want to see if something's wrong with you, what you do first thing, you take a blood test. If you want to see how is the state of certain natural ecosystems, what you do, you look at the water. What is the main problem with the superficial water we have nowadays? The nitrate pollution. 70% of the pollution of the surface water on the planet comes from agriculture. Okay, so this is the problem. Now the water companies which gives us water to drink, those of us who still drink from the tap, they have high costs and they really struggle with this. In dry season, up to 9% of their operation and maintenance costs is only for getting the nitrate out. They think about paying the peasants, the farmers, to use fertilizer more consciously and to lower their in Germany we call it Gülle. Gülle is this basically shit and so on from the cows, right? So to lower this, but it doesn't work. Why? Because they don't have the monitoring. Yeah, they don't have monitors, a system of monitoring in place to know how much nitrate is decreasing or not. Or they just spend 15 million US dollars for a reverse of osmosis unit. So our solution is this, is a water quality cascade sensor monitoring system. We follow the water. We follow the water in its flow, following the hydrological model, and we dispose sensors following the creeks and the rivers, and with this we isolate the farms. And we can see how much a farm is polluting. So how does it work? Quite simple. We have a again, I forgot a word. Basically, above, like a sensor or a group of sensors, the farm, and downwards. And we can see the quality of water upstream, this is the word, and downstream. And this, then it comes the next farm and the next farm. Here is the beneficiary, sorry for the colors, the water company, the state as well. So what is happening, we have these sensors or clusters of sensors which are placed by combining three models. the hydrological model provided by the water company, the digital elevation modeling we get from the satellite, and the economic modeling we will have from the farmers themselves. That means we need to know what kind of plants they are cultivating, how much, and what kind of cattle they have, how many. Now, the sensors are sending the data per 15 minutes, per hour, whatsoever, depending how are we going to power them. Are we going to power them solar? More often, are we going to use battery 6 hours a day? Every 6 hours, sorry. Sending it to a curation registry, basically, which only shows which one of the sensors works and how it works, like if it is in the parameters. Collecting server, we batch a score per day. According to that score, which is actually the KPI, this score will be compared to the KPI that the farmer himself sets. He will say, I will use this amount of fertilizer, which is translated in that amount of nitrogen. Then we compare it. How much are you? Above or below this? And if you stay below that, you will get prize, you will get money, you will get paid. And this is how we incentivize him. So we don't punish him, we incentivize him to keep his word. Then the water company receives the digital units of service and the physical units of service, the pool of the money, right? So the payment can be done by day using API, bank connection, or using tokens, whatever. This is not a problem. Yeah, basically the market is like this. There are 1.23 billion euro spent in European Union. We address first the European Union market alone for the nitrate. So of course we are customer oriented, so we are doing here business. We aim to a reduction of the operation and maintenance costs up to 9%. The product will be, of course, tailored for the partners. And then we will have a lot of data on water quality from agriculture, which is another story. Where we are now, we are in the market validation, trying to, it's very possible in the following month to get an LOI with a Riva from the Netherlands. Hello, Netherlands. Are we connected? I don't know. Are we? All right. Which is a water association of water companies, or with someone, I will not tell the name, in Germany, in northwest Germany. In the Netherlands, they have real problem with Gülle, with this, cow shit and so on. They are falsifying the numbers there. They really have bad problems. Okay, prototyping in spring. With the sensors on the market are quite expensive, so we want to make some improvements here as well. We met today with partners from Fraunhofer to develop a more suitable sensor which will be addressed specifically for this problem, so measuring only nitrate. We will use optical sensors, so no ion selective ones. Yeah, so what else? Yeah, of course, results of the case study and basically being ready to scale starting with 2020. We will develop this, as I said, together with our partner, and it will be profit sharing. He will have skin in the game. This means they will help us to get access to the market, and it will help us with scalability. This is our team. Van working in ecology and research. Yatan worked a lot on accelerators, agriculture around the world, Africa, Ghana, so on. And David, he is like really a sensor guy, the sensor specialist. The Waterhive. This is an interface. The sensors, we are aiming at. Imagine the sensors are placed along the watershed. One valley with its sensors communicates with the next valley, which has its own swarm of sensors. And they will want to be more of them, yeah, to replicate themselves. They ask for, because they are at the basis of healthy environments. A healthy environment is beneficial for both human and for them, because there will be more of them, and having an incremental power to self-develop themselves, to self-multiply themselves. This is the idea. Yeah. Thank you.
This is a 25-second delay, but we can ask questions in between if you want.
Yeah,
Presentation.
Very interesting idea.
Well, it will be difficult for you to go to the wormhole of this speaker because it's in Berlin. Unless you have a teletransporter, this will be difficult. But don't cry too loud, because we have a last speaker. His name is Dan, and he's from Team Kryha, and most definitely.
So they are basically the team to beat in this.
Yes. Are you on?
Okay, so.
No pressure.
Honestly, considering the pressure that has been given to me for this presentation, that this is last, that I'm going to explain to you how to build a hive mind, that I'm going to explain to you how to win this year's hackathon. Okay, let's try to do this. I'm going to try to do my best in explaining to you how to build a hive mind. But in the beginning, like, quick introduction, yeah, I work for Kryha. We are a blockchain studio here in Amsterdam, and we only work with large enterprises from like ideation to actually building stuff. And we build on whatever protocol is available. And one of the things that I'm going to talk about is Grex. And that was the thing that we won this year's hackathon with. And that was the team that participated. After 48 hours of horrible amounts of work, we actually built something and it worked. The main topic that okay, so this is going to be a long presentation. I know everybody is tired. If you don't understand something, I have enough time to explain and to go deeper into the slides. Please tell me about it and raise your hand. Questions till the end, but for now, let's just make sure that everybody is awake. So the first step in building a hive mind is actually to have workers. You cannot actually just have an AI that will operate and would do stuff. You need it to send orders to some sort of a fleet of drones or who knows what. So for the first step, basically, remember how the first layer of this three-layer approach was plugged in? Yeah, that's what you need. You need internet-connected agents. It would be great if they were autonomous and they could communicate to their own peers, but you really want to make sure that they can basically support running a full node, because that enables really cool things. So other than that, you really want to make sure that if you have one of these agents to be, let's say, an autonomous car, it should be able to drive. If one of these agents is a drone, it should be able to map an area. If this agent is whatever, it has to be able to fulfill one task at least. So give them that. Then just make sure that it's not doing this because, okay, note, I have a broken jaw, so sometimes I might actually glitch when speaking, but bear with me and I'll try to recalibrate. So the main idea is that they perform tasks not because you're telling them to, it's because it's in their own best interest. So you're paying them to actually do something. And they're like, oh yeah, I get money for this, it makes sense. So this is the big change of mentality. We go from I perform this because I'm programmed to I perform this because I earn money and this will actually guarantee me survival. That's why we really went with the idea that we want to run full nodes, because it gives you your own wallet, and you can also make sure that this agent does not rely on a central server because it's autonomous. So yes, this is the first step. You've actually built a decentralized workforce. This part of a presentation is going to be more or less like very conceptual, but there is going to be code afterwards. So if you're interested in, we're going to see. But you have this weird autonomous decentralized fleet of robots. They do things, but you don't really know who does what when, and you don't really know if they're ever going to improve. So if there's a robot from the 1990s that only knows how to, I don't know, dig in a specific way, you can't really make it improve. So if you have a homogeneous system and you want to make sure that they all communicate to each other, you want to give them some intelligence. We're not talking about a hive mind yet. We're just making sure that these robots can update themselves better. They can perform a task better eventually. If one robot has a very, like let's say it has 6 rotors and it moves in a certain specific pattern, and it gets stuck, right? Usually, to figure out how to get stuck is every time a one-time experience. And if a second robot also gets stuck, you need to make sure that it doesn't have to go through the same pain as the first one. So this is why we add federated learning, because they learn on the robots themselves without relying on a central server. This is really important because it heavily increases the efficiency of a system while still maintaining its decentralized aspect. One minor thing you should consider, it's currently, we're not really certain how to do it right now, but please make sure that you know how to do this. So we really want to make sure that these robots make ethical decisions. And these robots are not smart. They're pretty stupid. Like, they are single-task, single-minded computers. So we should embed some sort of a system that prevents them from harming us, because you know what we want to prevent, right? So this is one example. I'm a fan of Asimov, so I did choose this. This is really not what you should do, because, again, this is from a novel author. Make sure, but this is just one example of how you could implement ethical decision-making in a robot. It's very simple. It's very basic. You can actually code this, and you can script it as long as you have some sort of a visual visual detection system for humans. But again, then in that case, you have to rely on how accurate your visual detection system is. But it's a step towards that, so bear with me. Congrats. We have just avoided building Skynet. This is real. You can actually go there. It's actually a countdown to my birthday, but the point is, make sure that the next robot that you build is not going to eradicate the whole of humanity. I know there are camps that really consider that Skynet might better humanity by uniting us against a common evil, but no, wait a second. Let's do it slowly. Just make robots that will not stab you. Is this a hive mind? We have a decentralized workforce, right? So they work by themselves. They execute tasks by themselves. They own themselves. They do kind of improve each other's efficiency based on submitting new model updates, right? Might make sense? Nope. We really need a very important element in this entire system. So a task generator sounds weird at first, but if you look at it a bit better, like let's say that you have missions, right? So when we designed originally Grex, these were 4 potential missions that we really wanted to work towards. I know one of them is very far-fetched, but come on. If you have a swarm of robots that are only interested in doing one task, and they're all based on a blockchain where everybody has a replicated database, you only need to retrieve one in order to be able to retrieve the entire history of your entire mission. So planetary observation does not seem that weird anymore. And these missions are a very complex combination of tasks. You cannot give this to a swarm of workers. They will not understand what to do. And this is a really critical element of such a system. And same goes for building and search and rescue. Okay, that one might be a bit easier because there's only 2 tasks, like explore, rescue. But overall, you need something that governs these robots. And if we want to have multiple missions where many humans actually submit missions, what does it stop us from just generating new missions, having other people bid for something specific? I mean, the mission can be as weird as possible, but because we've implemented the ethics on each individual worker, we know that they will not theoretically harm us. But again, this is going to be another layer approach for the ethics, because sometimes in the global scale it might harm us, but in the local layer it will not. So this is a conceptual idea. We should discuss this. I am pretty sure that there's a lot of smart people working on this, and I'm not one of them. So it's not really going to be a really simple. Okay, fine. Due credit. OpenBazaar is remarkable. But it will not be able to do what we needed to do for a multi-agent system for robots, such as Nature 2.0. It will not work. It needs to have a very, very powerful AI to deconstruct missions into tasks and then to generate a task queue for all of these robots. We don't really have a system right now for this. And this is the whole point of a hive mind, right? We're here designing a system that can actually delegate tasks to robot, manage them, and even in the end, see which task is completed and if those tasks actually get rewarded. There's not much that I know of in terms of a blockchain space that is capable of this. So there are very many interesting articles. I heavily recommend reading the BigchainDB's trend articles regarding Nature 2.0 and AI DAOs. By the way, raise of hands if you know what an AI DAO is. OK, good. And the main idea is that Dimi explained it before, but you need to have this non-human-based mechanism of doing decisions. And as long as you can automate most of it, then you will actually have an arbitrary decision maker, which does not rely on big corporations, small humans with a lot of money. You can avoid a lot of problems of nowadays society. Why? Because basically, I did mention some of these before. So DLT really helps in a lot of elements of such a system. It's really nice, especially when you have a blockchain-based solution for a DAO, because you do get a lot of benefits of the incentivization mechanisms. Oh yeah, and you can actually make multiple AI DAOs interact with each other and then see which one comes up with a better solution to task that to all the workers. It's really fun. It's really interesting to discuss, but also it's not something that has been implemented yet. So this is all theoretical, because maybe some of you are going to build it at the next hackathon. I'd love to see that, honestly, because I personally want to build this, but I don't know how far we can get there just as Kryha, because this has to be a community effort. And I've discussed with many people, this is not possible to be built by one organization. And if they do, then it's actually a problem because it's a centralization point. So maybe as a community, we can work towards something like that. And yeah, manages the task queue for workers, but yeah, that makes sense. So finally, we did build our hive mind, conceptually. But these are sort of the steps that you would like to follow when creating this type of a super, I don't know, smart contract, let's call it like that. Something that manages more smart contracts, that manages other workers, that interact basically only based on payment. And if you want to actually, I know, with all due respect, like, there are different technology stacks that do things differently, but one of the interesting ways of thinking of how an AI DAO would interface with a worker pool is basically sending a transaction with metadata which contains the steps per each task once that has been computed. So in one case, IOTA's cubic protocol using the Abra language has kind of the same idea, but they use it for something completely different. So there are ways, people have tried to create this method of doing computations based on payments, which are very interesting, but there are so many things we have to figure out in order to get there. And why do we really care about this? I mean, we are an enterprise-focused company. We really like building solutions that make sense in the real world, which bring money eventually. Why do we want to build hive minds? Well, we kind of built the first part of it, and we really got excited about it. So there was this, this works, by the way. You can go there. The scaling on mobile is pretty bad, so I'm sorry. This is like the hackathon project that we managed to get running on servers. And it does work. It was pretty crazy to get it on a server, but the whole point is that it is a proof of concept. And that's what we built, and that agents actually don't have to interface with each other than through their network protocol. So this runs on BigchainDB. So as long as your network is synchronized via Tendermint, because that's the consensus layer of BigChain, it will work the same way as if you were running multiple nodes on one server. Because the simulation that you check is that, oh yeah, so the simulation resets every 5 minutes. So there is a chance that when you loaded it, it was actually ending, so you'd have to refresh the page. But those are minor things. And once they are synchronized, they actually work together towards completing a task. And the task that Grex is focused on is search and rescue. So these drones perform a random walk to detect an objective. This objective is randomly placed on the map every time the system restarts, which is, again, every 5 minutes, unless they actually find the objective and converge before the 5 minutes end. A couple of months, which is going to make it even easier. The documentation is, at the moment, not the best by far. It's pretty bad. But the beautiful part I'll explain after. So why everything is happening and why we're open sourcing it even further? Because it was open source under the Blockchain Hackathon, but we did go further with it and we improved it. Because we realized that what we wanted to build was actually based on a paper from an MIT professor called Eduardo Castello-Ferrer. And then we contacted him and we explained to him his own papers. Because we forgot about it. And he's a pioneer in blockchain for robotics. And he agreed to work together with us on this paper. And this is purely academic research. There is no token value behind this. This is an open platform for everybody to use. It's actually a boilerplate. And the whole idea is that blockchain or a DAG just add so many interesting elements to swarm robotics. Because in swarm robotics, you have a problem of auditability. In blockchain, you can connect to a node and you can see the entire history of all transactions as long as they're not encrypted. In swarm robotics, it's usually pretty hard to synchronize and to make sure that you can handle malicious agents. Once you insert the blockchain, yeah, I know it's very hard in terms of communications because you have to sign everything and then you have to send it to everybody. But the handling of malicious actors just goes so much better. So there are a lot of reasons to use blockchain in a swarm robotic systems, and that's what we did. We actually focused on a paper that explains the advantages of doing that. And this will be published early next year because we're still doing the review process with a publication. It's called The Ledger. So sorry that is not available yet, but the main elements of it are available in the code and in the results. We really encourage you to start building today with this because when we started the hackathon, it was a horror. Okay, the hackathon was amazing. I can't say anything bad about it. But for us, because we really wanted to build this, it was a horrible 48 hours. Because even for me, I don't remember how much I slept. It was really unpleasant. But winning it, it felt so good. So we want you to have a better experience. So for everybody who wants to participate, we really don't want you to be seasoned Ethereum coders, or you should know and learn any other stack instantly. No, the beautiful thing is that you can use abstraction. So I'm pretty sure if there's a developer here and they build applications, they're very familiar with MongoDB and they're less familiar with using PostgreSQL or MariaDB because those are SQL-oriented. You have to code per row, while an ORM gives you the advantage of coding per object, per collection. That's really nice. And that's what happens when you code in blockchain. You get stuck in coding for transactions. You lose the whole idea until you build your own abstraction layer. And yeah, that was one thing. So the other part is this interface. So if you've seen, yeah, I'll show you a picture afterwards, but also on Grex.ai, we built a front end that basically connects to one node and displays what every other agent is doing. You can edit it however you want, really. But for us, it basically just meant it's an easy way to see what actually is happening. Because you can always do console log and see what's happening, but a front end is always nicer. And actually, you can pretty much modify everything available in the mission. So the mission is our own stupid random walk algorithm, because it was 48 hours, we're not going to build an AI, come on. And it just really decides 50% whether to go left, right, or forward, or whatever. I don't remember anymore. It's in the code. You can just check it out. And you can make it way faster. You can improve it. You can connect it to Ocean if you really want to. And then you're going to have like a way better way of finding the correct path with actually object occlusion. So you don't have drones interfacing over each other. And actually, in that one, we do have two versions. The first one is with simulated agents, and the second one is with real agents. And at the hackathon itself, we coded. That code is still available in the repo, but it's deprecated, and it's with rolling drones from Parrot AR. I don't know if you've seen them. They tend to jump a bit. There is code that allows you to control them, which otherwise you'd have to redo it yourself. Just use our stuff, because otherwise it's just going to be painful. So in this wonderful conceptual idea that I've showed you with workers and everything, we built our own. So the first iteration of Grex actually used flying drones that were really terrifying, and they were really unstable. And yeah, we ended up calling one of them Twitchy, because you could never predict how it would fly. And they're all running on a Raspberry Pi B3, a free B+. And the advantage of running on an ARM, I mean, you're all used to running on your own laptops, your own software, because that's an Intel processor. It's not a problem. But the beautiful fact is that you're running a 64-bit operating system. And so are those. If you manage to install a different version of the operating system of Raspberry Pi, you can run the same software with Docker. So suddenly you have a very nice low-cost development platform. And that's basically what's going to help you a lot if you want to interface with real agents. And that's what we did. The code for running BigchainDB on the Raspberry Pis, I believe, is still under my Docker repository. But it's best if you send me an email regarding that, because that's slightly more complicated than just running the application. The ORM, yeah. Honestly, big thanks to BigchainDB and Ocean Protocol, because this has been like one of the best things that we ended up using when coding for this. Because adding abstraction to coding for blockchain changes your mindset. And it really allows you to focus on building agent-to-agent-based communications. And you don't actually have to think how your transactions are going to look. They end up looking like this. OK, maybe for some of you this is not beautiful. I find it amazing. Because you define your own model. And we ended up only using actually one model for the entire system. And you set that it's ID, location, action, whether it has detected or not detected something, whether the battery is full or low. I don't remember what cost is anymore. And the type of drone that it has. So in most cases for us, we were like test drones. How do you define your data? Well, drone name, this ID, create drone, location. This, oh yeah, I think this is how you create one. And basically, that's it. There is no, please connect your Ethereum wallet to this in order to create this transaction that you will have to afterwards change to another transaction. We have a theory how to create an Ethereum ORM. It's actually not that hard, but this was available at the moment, and we ended up using it. And yeah, to update it, that's all you have to do. Like, you cannot really tell me that this is blockchain coding. This is straightforward JavaScript. I mean, this is what we want you to use. It took us forever to figure out how to get this running. And also, fortunately, we ended up working together with the BigchainDB team to recode this for version 2.0, because they were sitting next to us, pushing to master, and we were sitting there testing for errors. It worked in the end, I mean. And this is the interface. I mean, you have a live version available wherever you have. And the main idea is that everything that is not yellow is fake. Those are just sitting there. Actually, you can click this one to open up your own webcam. But yeah. The simulated drones, they just run around, and they eventually turn orange once they detect something. So they do randomly walk everywhere, unless one detects and it turns orange. Once that one turns orange, you actually see all of them converging to that point, because that's how we coded them. You can implement way better stuff, but for us, it was the main idea of switching from blockchain-based coding to an ecosystem-based approach where we have agents communicating to each other via being full nodes. That is it. I'm pretty sure I am way below the time I was supposed to do, so feel free to ask me questions. Thank you. Oh yeah, and those are the results of all the 420 tests. Like, you can have fun, you can do your own graphs, you can run simulations. Enjoy. And for any questions, shoot me an email on dan@kryha.io. I'll be really happy. Please do so.
I just one specific question. I was intrigued by your comment that you said with blockchain or ecosystem programming, the way that you programmed, it's easier to manage the malicious actors. I was wondering what you meant by that.
I'm going to try to reference a paper that we were researching when writing ours. And basically what it stated, it was on a peer-to-peer based system, right, where you have no global consensus. you have an agent that, I think the paper was basically on having a 50 by 50 checkerboard with white and black tiles. And all the agents there were basically, their global goal was to identify what is the majority of tiles in the system. And usually, if you have basically non-blockchain related peer-to-peer communication, so an agent can go to one and say, I've seen the majority of this is white. And then, after a couple of moments, goes to another one, because they only communicate to each other. There's no global layer. It's like the majority is black. So suddenly, they have this inconsistency of reporting for data. While in the blockchain, if you sign every transaction, it's appended to a global ledger, it's pretty much impossible to fake that. Because if you once reported white, and then you go to another and you report black, he's like, oh, no, red flag, you're a malicious actor. And you can see how these type of systems with a very heavy communication overlay, or how do you call this thing that is layering on top, basically. The fact that with a blockchain, it's way more intensive to run these operations. But when you add more and more malicious agents, you can notice that in a blockchain system, it will consistently continue to outperform the non-blockchain system. So that's it. It's the fact that you have historical auditability and you can verify whatever agent actually says. So it's no longer a trust-based situation, it's verifiable.
But it's after the fact, not before, not while the process is in full gear.
Well, you can still check, and if the process is in full gear, if you do check, it's a signed transaction, right? So if it's the first one to report this amount from this particular agent with this key, you can make sure that this is true. And if you receive a different one, you can basically say that your previous notification was false. I don't know if that's a better explanation. Any other questions? Okay, cool. Thank you.
Thank you very much, Dan. Thank you, everybody, for staying alive and awake so long. We hope you enjoyed. We will be back after the holidays on the 16th for the self-actualization, our very last meetup before the opening of the... No? I was about to say something, but maybe you have something else in mind.
Because what you will see very soon is that we are going to do 2 additional meetups in this series. We have been talking with SingularityNet. It's also a blockchain system, but for decentralized AI algorithms. And we will be doing 2 additional sessions on artificial intelligence. The SingularityNet community is an incredible community of, I heard, 100,000 AI developers all over the world. So we said in the beginning we want to bring blockchain and AI together. And this is definitely a next step towards that. So we will have a session on development before the teams can register, so that you can make a clear idea of what you want to build. And in round about the 21st of March, there will be an additional session, Tech Deep Dive, SingularityNet, on how to build or how to cooperate with the AI developers in your hackathon team. So watch the meetup. There will be a mail with the exact data of these sessions, but it will be cool. Starting January 28th, you can start to register. In the Nature 2.0 track, we asked you something very special to build the unimaginable. That means we want to interact with you before you register for the hackathon. It will be 100 teams in the hackathon, but what they are aiming for is 250 teams that register to pick the best 100 teams. And we are here to help you to be amongst the best 100. We will have extensive guiding for you in the preparation, if you want to become a hackathon team. As soon as you have registered and you are one of the best 10, you will see that we have a whole team around you that helps you. We have video teams so that you can share your story on social media. We will have a TEDx coach that helps you prepare your narrative. We have people who make visual pictures of your thoughts so that you can share it amongst people. So we are really believing in that helping you to be the best is the thing that we are here for. And if you want to know how that is, ask to Gert-Jan, talk to Dan. They have experienced it last year and we have turned it up a notch. So, thank you very much for your time and your attention. Don't forget to register also in the Tinder for hackathon apps that was shown on the right side. Maybe, Douwe, you can show the code once more for the people who didn't. What you see, yeah, it's right on top, great. What you will see is that you can see who did you want to connect and on the second screen if they connected to you. And this will be also the app which will be sharing with all the AI developers. So if you have a great idea but you want to co-create with people who are great in AI, then this Tinder app is for you. If you want to create with a German ecosystem, this Tinder app will be for you. We will be sharing our story in the beginning of the year in London and probably in Switzerland. We will show this app. So you will have the opportunity to build an international team around you, because we believe that we have to help you to be the best version you can during the hackathon. Is there something you wanted to add?
No. This was Jan Peter Dominic, by the way.
Ah, yeah. Track owner of the Nature 2.0 track. Thank you. Yeah.
I have a question. Last time there was something with the code, DECMA, that would mean something, but...
Decentralized machines.
Thanks. That makes sense.
Cool. There will be an announcement of the hackathon organization in the coming days. And with this announcement comes a totally new platform to interact. We will share also this information with you during the newsletter. So there is a lot of nice, exciting things happening before Christmas. Have the best of holidays and see you again in the next year.
And drink the beers.
And drink the beer.